In addition to anonymous pipes, we also have named pipes. These have an entry in the file system, and associated with that entry there is an ownership and there are permissions like there are for any other file. From the command line you create a named pipe with the command mkfifo. And from within a program the call is also mkfifo. Here the second argument is of course the permissions that we want to assign to the file, to the mode of the file. Named pipes, like anonymous pipes, are unidirectional, and they impose a loose synchronization between a producer and a consumer. Opening either end of the pipe will block until the other end gets opened. But the communication uses normal read and write calls, and from a systems programming point of view there's really nothing new to say about the use of named pipes. Now, named pipes provide us with one model that can be used for client-server communication. The idea is that a server listens on a well-known named pipe name like /tump/mysrv as we have in this example. A client connects and sends some kind of request. Now the pipe is unidirectional, so if we want to get a reply back from the server to the client we need another pipe, and the question is, what do we call it? Well, one solution in order to guarantee a unique name for this pipe is to name it after the process ID of the client, 183 in this example. So now the client and the server can communicate. Do notice, however, though, that this only works within the local machine. This is not an IPC mechanism that works across the network. Here a second client connects and it gets an additional pipe to receive the replies coming back from the server. Now, most of the inter-process communication mechanisms that you'll meet involve some sort of name or address that identifies the communications endpoint on which the other process is listening and to which we must connect if we are to communicate. We've just seen that named pipes have a name in the file system. In the world of network programming, endpoints are identified by a port number along with the IP address of the server. In the case of System 5 message queues, for example, there's a numeric key that the parties must agree on in order to rendezvous. But for anonymous pipes there is no such name or address. That's why they're called anonymous. So it's not possible for two unrelated processors to talk through an anonymous pipe. The processors must have a common ancestor that created the pipe and handed the file descriptors down. Let me end here with a subtlety. With a named pipe, it's possible for many clients, many writers, to connect to and write to the same pipe. Now, Linux guarantees a minimum message size that will be written atomically to the pipe. What I mean by that is that the message won't get broken up and interleaved with bits of message from some other client, from some other writer. That minimum size is called pipe buff, and on Linux the value of that is 4096 bytes. Now, I don't have a separate program for you to demonstrate the use of named pipes because, as I've said, from a systems programming point of view, there's really nothing new to learn. So let's have a look at named pipes from the command line point of view. First of all, let's create one. Okay, and if we list it, well, the thing to notice in particular is the P in the very first character position, indicating that it's a named pipe. But notice it has access permissions and an ownership, just like any other entry in the file system. Let's try reading from this pipe, for example with cat. and you'll see that the cat has blocked at that point. So we'll hop over into the right-hand window here, and we'll run a command, let's say date, sending the output to the pipe. And you'll see that the output appears in the left-hand window. Let's try running another command in the right-hand window, again with the output going to the pipe. And this time you'll see it's the upstream process, the PS command, that's blocking because nobody has the downstream end open. The cat that I was running has terminated. So let's run cat again on that pipe, and we'll see that cat collects the output from PS that was written to the pipe, and if you hop over to the window on the right, you'll see that the PS has now terminated. So we have this loose synchronization between the upstream and the downstream processes. Finally, how do we find named pipes in the file system? Well, we can use the find command. We'll look in /tmp, and then we need a -type p to find named pipes. And there it's found a demo pipe and also an error message about a file that we're not allowed to access.